This next control chart that we're looking at has to do with measuring attributes. And so no longer am I using some sort of a measuring instrument to measure radius, diameter, circumference, or any other type of physical measure. All I'm really doing is I'm looking at a problem and I'm saying, oh, okay, this is the types of problems that I'm having. So for example, or in the book's example, what they're saying is they're looking at a hotel, and each day what they're doing is saying, well, how many complaints did we have? And so, there's nothing really quantitative about that. It's very qualitative. Oh, on the first day I had 4 complaints, so they just write down the 4. And so I'm not really tracking how many customers I had in the hotel. I am just counting the number of complaints that I had. So this attributes model does or can also have some sort of a chart where we can see whether we are within line or whether we need to be changing something to make something better. And so what I'd like to look at are these steps that I have to follow. The first thing we're doing is we're looking or using some sort of a Poisson distribution. Now, Poisson is a French economist, and we don't really need to know a lot about his distribution, but there are some pretty cool things about his distribution. One of them is I can find the mean just like I normally do, just like we have been doing. But in a Poisson distribution, the variance is equal to the mean. So I can write the standard deviation, which I will eventually, as just the square root of the mean. And I think that's pretty nice. I mean, you can look at the characteristics of a Poisson distribution. In fact, you probably should. They're in my lecture notes, but they're also on page 238 in the textbook. So, kind of moving along, how do I create this type of chart? Notice this is fairly simple. In fact, it's much simpler than some of the other charts we've looked at. If I don't meet the Poisson assumptions, I probably ought to redesign my experiment and just start all over again. So if I do, I need to choose the number of samples. Well, I'm actually going to be using the normal distribution to estimate probabilities. And so when I have these discrete distributions and I want to estimate them with the normal, I need to have a fairly large number of samples. So fairly large is not a very tight definition. Your textbook is gathering information across 20 days, and okay, I can live with that. So next step in the process, record number of defects per sample. So that shouldn't be recode, that should be record number of defects per sample. So I'm going to record it just like I have in this table, right? Day 1, I had at this hotel 4 complaints. I recorded it. That allows me to use it later. Day 2, there were 3 complaints. Day 12, there were 5 complaints. Day 18, there were 2 complaints. And so I am figuring out a way to record the number of defects per sample. So the next thing is simply to calculate the average, the arithmetic mean that we've been working with most of this semester. And so Excel has that capability. All I've got to do is go in here and calculate the arithmetic mean of these numbers of complaints. So this would give me the amount of complaints per day. Okay, so 3 1/4, the average number of complaints on a given day. All right, well, the next object that I need to look for is that control line, that center line, is this C bar that I just calculated. So I don't have to do any modifications. I don't have to do any further work. I can just go straight here and say, okay, my center line is just equal to this mean. And it's going to be constant all the way across my samples. So I should be able to just copy it. The upper control limit, notice that it looks an awful lot, if you remember anything from statistics, this looks very, very much like a confidence interval for a normal distribution, where this letter Z stands for number of standard deviations. So we have our choice. We can choose 1, 2, 3 standard deviations. Probably wouldn't go any higher than that because then it starts losing meaning. But we're going to choose z equal to 3. So notice what I need for this upper control limit. I need the mean. I'm going to add to that 3 times the square root of the mean. Why the square root of the mean? Go back a little bit. We're working with a Poisson distribution. A Poisson distribution, the mean and the variance are the same number. So the standard deviation, square root of the variance, square root of c bar. Okay, so let's go back. I need c bar. So that's the square root of 3 1/4. Z that we're going to use is 3. So I'll put that in there. And then the upper control limit, all I have to do now is collect my information. It's c bar plus z times square root of c bar. Okay. All right, well, what do I need in this lower control limit? Well, first of all, I can't have a lower control limit that is less than 0. So I want to make sure that I'm not dipping down below 0. So that's why I'm using this max function. If I'm going to use the max function, then I'm going to input this equation. So I have c bar minus the number of deviations, which is 3, times the standard deviation. So my max function, I see I didn't put the other side of the function in there, tells me that my lower control limit should be 0. Okay. All right, well, to create my picture, just like before, I need to create ordered pairs in Excel. And so I need the upper control limit, which is this number, and I need a lower control limit, which is 0, which is what we calculated. I need to make sure that's an absolute reference. And then I'm just going to copy all the way down. Okay. At this point, I can go ahead and create my picture. And there is my C chart. All right, well, from this point on, everything is just aesthetics. So again, maybe I want my line to be black. I don't want any dots, so I go to the marker and take away the dots. Then I go down here and take away my dots. I go back to my line. I make it a black line. And then the center line. For the line, I want it to be red. And I like those long dashes because it distinguishes it from all the other lines. And then the markers, I want them to disappear. So I'm going to remove them. And there's my control chart for our first non-continuous data, just counts this time. Okay? So hopefully this is helpful when you construct your C charts. Hopefully you can go back over this a few times and make sure that you understand things clearly. Until next time.